This is AP Calculus AB. This is the 2003 release question number 5. Let f of x be 2x squared minus 6x plus 4, and g of x be 4 times cosine of 1/4 pi x. Let R be the region bounded by the graphs of those as shown in the figure. Well, the first thing we'd want to figure out, which of these functions is which? Because if we don't know, we're not going to know which one to put first. Hopefully you recognize that this is a parabola, and since the lead coefficient is positive, it's going to open up. It's going to have a minimum, which leads us to believe that this function here has got to be f. So this little fella here is function f, which means, logically, this other one has to be g. Hopefully that makes sense. A, find the area of this region R, because it says that region R was defined by the area between the curves, and it shows it right here in the drawing. So, part A, in order for us to find this area, we have to integrate from our upper and lower bound, and we can see here that they intersect here at 0, x is 0, and we can see they intersect at x is 2. So that makes it easy. We don't have to do any work to figure that out, going from 0 to 2. Then we got to figure out which one is higher and which one is lower. Well, it sure looks like g is the higher one. That's the one that we have here written in blue. Function g, since we have to actually integrate this, is 4 cosine of 1/4 pi times x. That is a function. I'm just going to put that in parentheses for emphasis. It's necessary. We're subtracting from the second function, which the parentheses are necessary, because we're subtracting and it's more than one term. Now, what I would recommend on a problem like this, because we're going to have to use a substitution for this because we can't do this directly, or at least, I mean, you probably could do it directly if you can do some work in your head. I haven't taught you to do it that way. So what I'm going to do is, first of all, I'm going to write this smaller. I'm going to separate this into two separate integrals. So I'm going to have integrating from 0 to 2, 4 cosine of 1/4 pi x dx. Then subtract from that, integrating from 0 to 2, 2x squared minus 6x plus 4. And I'm doing that because the first term we have here requires a substitution by the way that I taught it to you. So I'm going to set u equal to the angle, which is going to make du over dx equal to 1/4 pi. du is going to be 1/4 of pi dx, which is going to make, if I multiply both sides by 4, I'm going to get rid of this 1/4. And if I divide by pi, I'm going to have pi on the bottom. So now I know that dx is 4 divided by pi du. When I make this substitution, I only have to substitute into this first function because there is no 1/4 pi x in this one. This one I can just integrate straight away. Nothing special has to happen. But this first one, I can't integrate it straight away. I got to use some substituting. So I'm going to integrate. I'm going to pull this 4 out to the front. I got cosine. My angle, I'm saying now, is a u. I've substituted in for that. Let me change the color for your viewing pleasure. And then I'm going to replace dx with 4 over pi du. Now I got to be super careful right now since I substituted in for u, and I don't want to substitute back in for u later. I'm going to change the upper and lower limits of integration. The upper limit was a 2. But this upper limit that you see here is an x equals 2. and this 0 is an x equals 0. Well, if I'm replacing in for the x's this u, so to figure out what u is, I got to take 1/4 pi times 2. So u is going to be 1/4 pi times 2, which is going to be pi over 2. And here on the bottom, u is going to be 1/4 pi times 0, which is going to be 0. So I'm going to ignore this for the time being and just focus on this so we can see what's happening here. I can pull this 4 out to the front and also the pi. So that's 16 over pi integrating pi over 2, 0 to pi over 2, and then it's cosine of u du. The second function, we can integrate directly with the x's. This one has u's in it now, the first one. I don't need to change the upper and lower limits at all. So if I take the antiderivative of this, I'm going to get 2/3 x cubed minus 3x squared plus 4x, evaluating it from 0 to 2. If I just want to check to make sure I integrated this right, I'm going to find the derivative, just make sure that it checks out. It does. So then as I continue with this, I'm going to put a 2 in for each of these x values. And then I'm going to subtract from that, putting a 0 in. And hopefully you can see if I put a 0 in for each of these terms, it's all going to become 0, so I'm not going to even bother. I'm just going to say minus 0. This first integral, which I got a ton more work to do. I don't have a ton of space. I'll figure it out, I guess. I'm going to have 16 pi. The antiderivative of cosine of u is sine of u. We're evaluating it from 0 to pi over 2. Subtracting from it this mess here, 2 cubed. 2 cubed is 8. 8 times 2 is 16, so this is 16 over 3. Over here we got 2 squared, which is 4. 4 times 3 is 12. And then we got 4 times 2, which is 8. If we substitute in here with pi over 2 in for the u, we're going to have 16 over pi times sine of pi over 2 minus sine of 0. And then over yonder, I'm going to have 16 over 3, a minus 12, and a plus 8 is a minus 4. I'm just going to copy this and bring it over so I can see what's happening here. Sine of pi over 2, that's 90 degrees. That's a positive y-axis. Sine is the y value, which is 1. Sine of 0 is on the positive x-axis. That's 0. And then over here, 16 thirds. We're going to change the 4 to 12 thirds. So here I'm going to get 16 pi. And then I'm going to have 16 over 3 minus 12 over 3 is 4 over 3. So that's certainly enough. That is the area between the curves. You would get, on an AP test, according to my sources, 1 point for that correct answer. You'd get a correct point for writing this integral. You'd get a correct point for integrating this correctly. You get a correct point for integrating this correctly. 1, 2, 3, 4. That's worth 4 points. Yeah, I think that's it. B, write but do not evaluate. We like those because that means not a lot of work. An integral expression that gives the volume of a solid generated by rotating about the horizontal line y equals 4. Let's go back to our picture. Y equals 4 would be a horizontal line at 4, like so. We are revolving this around like so. The further distance between that green line and the curve is the function f. So I'm going to write this down below, but I'm just going to write it up here first so we can see the graph. Actually, tell you what, I'll cheat and I'll bring this graph with me. Just so we can see what we're talking about here. That didn't work at all. Let me try that again. There we go. So we need to know what the bigger radius is. And as pointed out, the bigger radius is the distance between this line y equals 4 and f. So you take top minus bottom, that's 4 minus f of x. That's what r is. Well, to find the area of a circle, it's pi r squared. So we have to square the r, so I have to square this. And I'm just going to leave it like that. There really is no need. There's no need to do anything with that other than leave it like that. Little r, that is the distance that the axis of rotation is to the closest curve. That's g in this case. So it's upper minus lower. That's what r, little r is. Area of a circle is pi r squared, so we need to square it. So we're supposed to write but not to evaluate this expression. And the general formula for this is the volume is going to be pi times the integral from a to b, upper and lower bounds of big R squared minus little r squared with respect to x, sometimes with respect to y. So in this case, our volume is going to be pi times the integral from 0 to 2, because 0 and 2 are the upper and lower bounds. Our r squared is 4 minus f of x. That's being squared. We're subtracting from that our little r squared, which is 4 minus g of x. And let me change these to parentheses, because then I have a bigger group with respect to dx. As far as points go for this, my understanding is, you're going to get 1 point for the integral. You're going to get a point for making sure to remember pi, and you're going to get a point for the correct upper and lower bounds. You could write, instead of f of x, this function that you see here. Why bother? It's just going to possibly create problems. 99 problems are writing out the functions one. Last one. The region R is the base of a solid. Find this solid. So we're not revolving anything, we're finding a solid. Each cross-section is perpendicular to the x-axis is a square. So here's the formula for this. The volume, we're going to integrate from a to b, and then we take one of the functions minus the other. I don't know what we called it before. I'll just do generically h and k. This is not part of your work, by the way. This is just me explaining it. So in this case, if you look at this picture that we see right up here, once again, this picture is not part of your work either. To find the volume of this solid, we're going to integrate from 0 to 2, and our functions, it doesn't really matter which one that you do. Usually we do top minus bottom, but the reason it doesn't matter is because you're squaring this whole thing. And if you're squaring this whole thing, whether you have those backwards or forwards, when you square it, it's going to become positive. As far as points go for this, you're going to get 1 point for the proper upper and lower limits of integration and 1 point for the proper integral. Yes, you could write in, instead of g of x, you could write 4 cosine of a 4th pi of x, and instead of f of x, you could write the other function, but once again, why bother? Hopefully that was helpful.